So, so what we are going to learn in this module is about two different things primarily. The first one is let us focus and understand what's the difference between organic and inorganic compounds, okay? Because once we know those differences, we can actually focus on what is the different categories within the organic compounds. So focusing on different types of hydrocarbons, such as there's alkenes, there is alcohols, all those different kinds of hydrocarbons. We're going to focus on that. But before we even do that, what I did was I started and I was trying to see how much back I can go to make sure that when you start, it doesn't feel like, wow, this is like hardcore chemistry. It doesn't feel like that to you, okay? And we will end with structural isomerism, and you will see how that correlates really, really well with module 2. So it's very important that we learn a little bit of structural isomerism. So that's just the last 2 slides. And after that, we would be just finishing up the assignments and quizzes and such. We have gone over this, so I don't want to spend a whole lot of time. Please make sure that you check for announcement. One of the best ways for how I find time is that I structure my time, and I say that always at this time I will sit down and study this, or I'll do this. So I'm not saying you should do it, but I'm saying it might help you as well. So I guess I'm motivating you to find a certain time during the week to do it. So keep yourself a little structured, okay? Any questions you have, please share during office hours or email, whatever works for you, not for me. What works for you, please do that, okay? You can also put comments and questions in discussion forum. You should complete the quiz and the assignment, whatever that is, on time. Make sure you check your grade. And in an assignment, if you know you didn't do well, you got 12 out of 20, you come back and we kind of discuss, and then you will have, within that 1 week, you might be able to resubmit it. So make some good use of that. You don't want to check your grade after 3 weeks and say, oh, I guess I messed up this assignment. If you're scoring more than 80%, great. If not, then please, we really want to do well, okay? I want all of you to do well. So biochemistry, as the name applies, is the application of chemistry, but in the study of biological processes. So it's really, really important for you guys. I know you are aware of this, especially I'm emphasizing in dentistry, but people who are in allied health really very well know that anything that you do, right from blood work to whether you are giving a patient like glucose or whatever is happening, it's all related to what is happening inside the body. And essentially it comes down to what is the biochemistry, or what is the, how does the body has different chemicals that are responding to different things. So here is just an example for you to follow, that the biology of teeth, how a cavity is caused, how are certain chemicals promoting teeth whitening, all of these, they have an underlying basis. In this course, we are exploring the basis. We are trying to understand why is this happening? And once we understand the why, the rest of it becomes much more easy to understand and much more logical. Okay, so there are certain slides that I can skip because they're just fun slides. They're there for you. And we use xylitol and gum, which is not digestible by bacteria. So that's something which we can use as a sweetener, and it doesn't really do anything in terms of damaging the teeth. Okay, so this is where we start. We're going to start with atoms. And what are atoms made up of? So atoms are made up of 3 subatomic particles. There are protons, there are neutrons, and there are electrons. And the protons and neutrons are inside what we call the nucleus. So right here, the reds and blues. And I hope everyone can see the slides, because if you can't see, then you should let me know. And the electrons are circling around. Okay, so I want to pause here. I want to ask if you are familiar with this model. I mean, I hope you are. And or let me ask. You are familiar. Okay.
Yes.
And if you're not, and anything seems confusing, just tell me right away, where is the confusion? I'll help you. Protons are, thankfully for us, proton and positive start with P. And throughout the course, I'll give you a lot of different tips, which will help you memorize things. So for me, protons are positive. That's how I remember. Neutrons are neutral. So it's kind of nice, just kind of goes together. And the rest of it, which is electron, is negative. Okay, so protons and neutrons are present within the nucleus. Electrons are around. I guess this is a simplified model. I mean, this is not exactly how it is, but this is how the best way we can learn. Now, this being the carbon atom, which is going to be the focus, we're going to be talking about carbons so much, carbons, carbohydrates, carbon focused molecules. So just looking here, we know that carbon atom has 6 electrons, 6 protons and 6 neutrons. So these are this is what makes. Now, another thing that we need to know is, so just a little more detail, and at least in this one, I had some audio put in there, but now we have the complete lecture, so it shouldn't be a problem. So when we say the nucleus is the center, in the center, and it is kind of heavy. So the question is, why is it heavy? It's just because the neutrons and protons have one atomic mass unit as a charge. So AMU stands for atomic mass unit. So imagine that both of them have positive charge. I mean, not positive, sorry, both of them have, proton is positive charge, both of them have one AMU mass, then the entire mass is focused in the center. Now you can say, how can something like electron have no mass? I mean, it does have mass, but it's really, 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 really small as compared to neutrons and protons. Okay, so that's why we kind of almost say this is 0, and the rest of it have mass as 1. Now, why are we studying this? We are studying this because we are going to soon look at periodic table, and it'll become extremely essential because in periodic table, you will find 2 numbers. One is the mass number, which is the number of protons and neutrons, which is the combination of both of these, which is 4 in case of helium. And the number of protons in the nucleus, just protons by itself, is the atomic number. So 2 things to remember: mass number, atomic number. And mass sounds like having a lot of weight. That's the one that's bigger. Atomic, smaller, 2. So you may ask, is mass number always going to be larger than atomic number? Absolutely, because it is usually, I mean, it's kind of, at least for smaller ones, double, like twice the number of protons or neutrons. So that's why it's twice the number of atomic number here. Anything from this slide that you would like me to clarify? So what happens is, and this is all what happens in nature, this is not something made by man, different types of different atoms can exist in different forms. So they're called isotopes. So they're kind of like brother sister kind of situation. Like they are belonging to the same atom, like they're hydrogen, but there is variation. What is that variation? You can see here, just signified by colors. And just for your reference, proton is not orange, or not yellow, and neutron is not blue. It's just something that I've indicated here. So neutron, there is no neutron present in hydrogen. Hydrogen is unique that way, no neutron. But deuterium, which is an isotope of hydrogen, has 1 neutron. And this one, there is 2 neutron. I think I need to fix that. There is an error here. I think the mass number is what's given here. I can fix it and reload it. So atoms of the same element that have the same number of protons, but different number of neutrons, are called isotopes, and different isotopes have different mass. So you can see this is 1, this is 2, and this is 3. And which of this is radioactive? Tritium is radioactive, and the radioactive ones, are the ones that we need to know a lot more to work with. They are something that can harm the human body easily. We're going to learn a little more about it later. Okay, so so what happens is that you might be hearing of things like elements, molecule, and compounds. You might have heard of it in different subjects, but we're just going to do a small clarification. Okay, elements are made up of only one kind of atom, whereas a molecule is a combination. How do I remember this? I remind myself water is a molecule. And I immediately know, oh, water is H2O, which means molecules are always a combination of atoms. Okay. And and the compounds are always made up of different kinds of atoms. So molecule can be something made up of only one kind or multiple kinds, but compounds are always different kinds. So for example, hydrogen or oxygen is not a it's not a compound, whereas water or CO2 is. So the difference here is molecule has everything, element is pure, compounds is always a mixture in that sense. So here are some examples shown to you, examples of elements and examples of compounds. Okay. So if there is any question, do let me know. You can also put in the chat. So we know that there is, what happens is that cells in human body, there are 60 trillion cells, about 100 trillion, like 60 to 100 trillion, depending on the stage of human growth. So all the 100 trillion cells, they look pretty complex, but most of them have, they are constructed, everything is constructed from atoms, but most of them are similar in what makes them. So there are 25 different kinds of elements that are essential to life, which make up all the different kinds of cells. Okay. And these are arranged in what we call as periodic table. So if periodic table is something that you're not too familiar with, I can separately explain, but if you are familiar with it, then I think you have a head start. So these are learning checks, are something that I want you to do by yourself. There should be pretty self-explanatory. For example, question number 6, what do you think? Are these isotopes?
Yes.
Yeah, yes, they are isotopes. And the reason is that, what is the reason for that?
Because the mass number is different to the atomic number. The atomic number stays the same because it's on top of the periodic table. However, the mass number not always change, but depends on the problem, it can change.
Yeah, and
Yes, we got the same number of protons, but different number of neutrons.
Perfect. Yeah, that's exactly the answer. So you both kind of covered it, and yes, so there is more neutrons in here. So just sharing with you, you can do it here, and also just to give you an idea, when you see questions like this, you will always remember that mass is the one that's greater. So 14 would be the mass. Atomic is smaller, that would be here, that's number of protons. And what is the element? That is N. So this is something that you can do. And like I said, that the initial process of starting to learn this sometimes is a little challenging. So I would like you to share with me as soon as you have a problem. I really liked one of you shared that, oh, I don't get this answer, and we kind of went over it. I think it was on GroupMe, but you can also individually message me. Periodic table. This is how a periodic table looks like. I'm sure many of you are familiar with it. And the yellow ones are the ones that are present in bulk in the human body. Then there are trace elements, and then there are essential trace elements. So these are like really very rarely found in some species. Okay. So here is a little YouTube video where you can go and watch, but I want you to just look at this, that the periodic table increases with atomic number based on atomic number. So we start with hydrogen, go to helium, lithium, beryllium, boron, and you can see number 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the main thing to remember, one of the important things to remember in the periodic table is this last row. And this is the elements which are, I should say last column, I'm sorry. Last column, which is the noble gas or noble elements. And, they have the perfect configuration. That's exactly how other atoms want to be. Okay, so that's the desired configuration. And you will see the importance of this very soon in next slides. This is something you can easily read by yourself. I'm going to skip this one. Just telling you also here that different elements have a lot of importance because they make these molecules. And then those molecules make the macromolecules, which we are going to study one by one in each module, followed by these macromolecules make larger, which is the organelles inside the cell. Oops, sorry. Ooh, what happened? Okay, and then finally that organelles complete the cell. That's what makes, so everything finally comes down to the elements. And I personally, for me, the fascination that I have in science is that for me, it's a lot of satisfaction when I understand everything, the underlying basis. And that gives me, like, I understand the complete cell. And I hope you have some of that fascination as well in science. So living things are made up of organic and inorganic molecules, and organic are typically carbon and hydrogen and their derivatives, and inorganic do not contain this carbon-hydrogen combination. And one of the excellent examples are things that you see, like sodium chloride, such an essential, ingredient. Like we know we have salt all the time, just like sugar, but sugar is a organic and salt is not. So those are some of the things to note. Now about the properties, there are two slides with properties, and so they just talk about how organic compounds always have a lower melting and boiling point, whereas inorganic have higher. And you can also think about examples that you kind of know, lots of things such as, there's methane, ethane, very low boiling points. Flammability is high. We know that as well. And they're not soluble unless a polar group is present. So these are some of the things you can look at. And even here, so I would urge you to go this by yourself, because I want to really, really get down to understanding some of the important things. Okay, so we are now going to start looking at the organic compounds, because that's where the majority of especially the structural part, where people get a little stuck. And that's what I want to cover. Okay, so if we are looking at this atom structure again, okay? And I know this looks really, really simplified, and maybe this is something that you have learned, but in reality, they're not exactly like that. I know this kind of reminds us of the solar system, but it's not exactly like that. Okay, so there are orbitals. Okay, so what happens is they don't have sharp boundaries, wish they had, but they don't. They have defined spaces, but they don't have sharp boundaries. So what are these orbitals? Because we have heard of orbits for planets, but we haven't heard of orbitals. So these orbitals, they have even names. So let's see what their names are. So it starts with S, P, D, and F. So these orbitals, they have their energy levels, and S is the first level. It can hold 2 electrons. Then P can hold 6, and so on and so forth. Okay, and then these orbitals even have a suborbital. And if it's sounding even a little bit confusing, don't worry. We are going to cover it very, very nicely in the next few slides. So from orbital, we started talking about suborbital. So suborbitals can hold up to 2 electrons with opposite spins. And this is what, I don't know if you've read this before, but that is Pauli's exclusion principle. So this one, they're paired opposite to each other like that. Now comes the actual part. We have an orbital, which is, there is the first one, S, which can hold 2 electrons. P can hold 6. And we're not going to worry about D and F at this time, because we just want to learn the basics well. Okay, so we'll start with hydrogen. Hydrogen has only 1 electron. What does it mean? It means that in the 1s shell, it can have only 1 electron. So which means that it doesn't have a pair. If it had a pair, hydrogen will be happy. Okay, so we're going to remember that as we move on. So it wants to complete its pair. And this is just showing you the structure. All you need to worry about right now is the 1s. So we're going to take a look at all of these. I said that the hydrogen has 1. If it had 2, it would be happy, which means that it would have that noble element configuration. It had the perfect, like it has the, two electrons paired opposite to each other, it doesn't need to interact with anyone. Okay, so we are going to look at now lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, and then followed by neon. So neon also is right here. So whatever is right here, everyone wants to be like that. That would be the basis of forming all the bonds. Okay, so we are going to see why is that the basis. Okay, so this is an important slide for us. So let's try to understand why. So we're going to correlate here what happens with each of these elements. So hydrogen with 1 has just 1 electron like that, and the helium has 2. Lithium has 3. Okay, now the thing is that the 1s is full. So we have 2s. We'll start 2s. And we won't go beyond the 2p. So you don't have to think like, oh my gosh, this is all new. And I've never learned this before. So if you see here, there are 3. So 1 pair here, followed by 1 here. When there are 4, a pair here and a pair there. Similarly for boron, followed by carbon. Now I'm going to stop at carbon and ask you how many are missing for carbon to be having a completely full shell, just like neon.
Yeah.
4.
4.
Okay.
4.
Okay, so yeah, so there are four are missing. So let me just draw this here. So I have this pen in here. Guys, if you are not asking questions, maybe you want to mute yourself, you know. Okay, maybe this is not the best. Okay. I might have to mute some people. I don't want to, but yeah, please don't be offended, because I just want to make sure that you're not recording any disturbance. Okay. So if you see here, carbon would be in a good shape if it had just 4 more electrons. That's a really, really important thing. You will see how important it will become. And in the following slides. So similarly, nitrogen would be happy if it had 3, oxygen will be happy if it has 2, fluorine would be happy if it has 1. And neon doesn't care. It does not want to interact with anything. Okay, so we first fill 1s, then fill 2s, and then fill 2p. And we don't need to know more than that for now. So that is the reason why different elements form bonds. They are trying to make sure that they attain the noble element configuration. So they can gain electrons, they can lose electrons, they do whatever they need to do so as to, or share electrons so as to attain the configuration as the last column of the periodic table. Okay, so for example, hydrogen. Hydrogen has 1 electron. What happens when a hydrogen atom interacts with another hydrogen atom? And they form this bond where they can kind of share the electrons. That's really nice, because now this hydrogen can claim, oh, I have two electrons, and this can claim I have 2 electrons, and they both are much more stable now. And this is called the hydrogen bond. And the representation you are seeing is the Lewis diagram. So when you see these dots, that's Lewis. So now that hydrogen has managed to complete its electrons in its orbitals by combining with another hydrogen. It's kind of win-win. You know, you'll see it's kind of win-win situation. So what about carbon? I know we just discussed that carbon needs 4. So what happens here? So let me just try to make this a little bit, let's see. Okay. So if you see here, let us make the carbon ones like green. So carbon had 4 electrons. Now you will say, I don't see the 4. So I'm going to help you understand this by making the green arrows as well. Okay. So I know you don't see 4, you see only 2. So let me first make these green. And I'm going to remove this from here, remove it, and then put it here. Okay, so how do I remove it? I'm going to mark it with the red. So I've removed it from here and I have added it over here. So now there are 4 electrons. And if the carbon got 4 other electrons, then it will attain the noble element configuration. And so what it does is, it does a trick, okay? It says to hydrogen, hey, hydrogen, you have only 1 each. Don't you need 1 more? So hydrogen says, yes. So it says, okay, I'm going to share 1 electron with you. You come with me and bring 3 more friends. So hydrogen brings 3 more hydrogens. And so hydrogen has now 2 each. Oops, I'm sorry. This can do funny things. And then hydrogen has now 2 each electron. So its shell is complete. And the carbon, which invited 4 hydrogens, has now 8 electrons, which I'm going to draw by a black. So it's going to be like 1 from hydrogen, 2 from hydrogen, 3 from hydrogen, and 4 from hydrogen. I want to pause here and ask you, did you understand why hydrogen tries to bond with, carbon tries to bond with 4 hydrogen for the completion of its shell? Do you understand that part? Are there any questions?
Can you just repeat what you just said, please?
Okay.
Can you do one more example too, if it's possible?
Yes, it is very much possible. And this is very, very important. So I don't mind repeating it 10 times. Okay. So carbon, okay, I'm going to just say here that the carbon, if just let's look on this figure now. Okay. So carbon was all green. So I'm going to go back to green. So carbon had these 4, oops, why did that happen? So carbon has these 4 electrons in its outer shell. Okay. They're symbolized by the 4 arrows. I'm going to show you what those 4 arrows are. These are the 4 arrows. So this is 1s2 is already done. We are focusing on 2s2 and 2p2. Okay. So 2s2 and 2p2 had 4. They got distributed like that. And we are looking for 4 electrons from somewhere. We don't know yet where. We're looking from, we always want 4. Carbon needs 4 something to help fill its shell. That's all it cares. It says, I want to be 1s2, I want to have 2s2, and I want to have 2p6. And when we look at carbon, carbon is 2p2. So carbon is not 2p6, but it really, really, really desperately wants to be 2p6. Okay. So what it says is it invites for hydrogen. It says hydrogens, you have only 1 atom. Don't you need 1 more? If you have 1 more, you will be happy because you're going to have 2 and then you don't need anything else. So it invites 4 hydrogens to form bonds. And when the 4 hydrogens comes, each hydrogen thinks, wow, I'm at a great advantage because now that I'm here, I have completed my shell. I needed only 2 and I have completed my shell with the carbon. And the carbon is also excited because carbon is like, I have now 8 electrons. Okay. So if you see here, by forming 4 bonds, 1 bond with 1 hydrogen, 1 bond with 1 hydrogen, 1 with 1 and 1 with 1, it has completed its shell because it needed 4 extra. So it has added those 4. The ones you see here in the black are added by hydrogen and the green ones were from the carbon. Okay, I do know that people have difficulty understanding this. So if you can share with me, if you have any questions, then I can help you understanding this better. Okay, yeah, and
carbon needs to have 2p6.
Say that
And
again.
I just feel like this is one of those kind of things where you just have to keep practicing at it. Like I would like to keep doing a few of them to understand more.
Yes, and so you don't actually, thankfully for us, we need to just understand that carbon needs 4 and you can replace that. It doesn't have to be hydrogen. It could be something else. It could be something else. So, I mean, yes, it needs practice, but I think it more needs revisiting and seeing, oh, this is how it works. You might have to revisit the slides um, rather than thinking there may be more tricky questions like this. Actually, there may not be more questions using this because this is only for your understanding.
Oh, okay, good to know.
Yeah,
Okay.
so carbon completes the configuration of 8 electrons, 4 are shared with hydrogen. And also note that each hydrogen also gets 2 electrons and 1 shared with carbon. So both are happy. Okay, so in the
Okay.
end, we have a happy, carbon hydrogen combination where everyone's orbitals are full.
Okay.
I'm going to clear this, but you will see the application of this. It doesn't end here. I try to make it easier for the next slide. So basically, I made this like this guy, carbon, and he always has 4 hands, and he always wants to use all the 4 hands. Something has to be in each of the hand. It has to combine with something, and that is the basis of many things in your assignment. Okay, so carbon always has 4 bonds. It can be with hydrogen, it can be with something else. You will see soon. Okay, and we can come back to this slides, like I said. So I'm going to skip this for a minute because this may confuse you. So now we will try to understand why the carbon forms these different combinations of things. Okay, how does it form? Why does it form? Okay, and when we are trying to form this, I have shared with you a trick. The trick is you have to know prefixes and you have to know suffixes. Okay. Once you know the prefix and suffix, you can combine them to make the compound. Okay. So organic compound. So for example, you might have heard of the name butanol. So I'll share with the list of prefixes with you, like butane, propan, like that. And the suffixes like all or al, like that. And then you just combine the prefix and suffix to make the word. So what is the prefix that we are talking about? We are talking about the number of carbons. Don't look at the hydrogen yet. When the number of carbon is 1, it's methane. When it's 2, ethane. 3, propane. 4, butane. You have to remember only these 4. After that, it's almost like geometry. 5 is pent, 6 is hex, 7 is hept, 8 is octet. Okay, so like that, you can remember at least to quite some distance, you can remember that. But the first 4, I'm sorry, the first 4 you have to remember: methane, ethane, propane, and butane. They're really, really important. You'll keep seeing them. And whenever I'm confused, I'm like, oh my gosh, I'm trying to remember this. What I do is I'll write it down, I print it out and keep it next to where I study or where I sleep, so I can just kind of refer to it again and again. Okay, so this is your prefixes and this is your suffix. So going back to the prefix, if someone asks you to make a butane or a pentane, you would go back and see what is how many does it contain? Oh, it contains 4 carbons. Okay, I must include 4 carbons in my structure. If someone says make a 5 carbon or 5 hydrocarbon alcohol, you'd be like, what is 5? Oops, 5 is pentane. So I need to make a pentanol. So you are going to refer to this chart to be able to convert the language into number of carbons and vice versa. Okay, so what about the suffixes? It looks like the suffixes are more confusing. Not really. You have used many of these things at home. For example, you must have heard of ethanol for sure. We have, the hand sanitizers, they use ethanol. So you can, correlate it to things that you've used. So that is that. Now fluorides, you use fluorides in toothpaste. Okay, so these are the things that you have done. So as long as you know that there is a certain, I guess, a combination associated with each of these groups, you will be fine. Alcohols are always OH and they end with OL. Understood? Alcohol, all. And similarly, there is haloalkanes, which end with fluoride. Okay, so we're not talking about sodium chloride, but we're talking about in combination only with carbons right now. Ethers, acids, and don't rush to remember this. Just keep this slide as a referral slide. I need to refer back. That's what you do. Okay. All right, so now we are going to look at the first and the easiest hydrocarbons. And I'm going to actually start with the next slide because that will keep it easy. So let's look at this. We talked about, carbon with 4 hydrogens. Does it have a name? Yes, it's called methane. And you might have heard of the gas methane, and that's what it makes. And that's the name, that's the Kekulé structure. That's the condensed structure. When you put C here with the H, like add all the H and put it here. And that's the ball and stick model, which you also will see in the assignment. The black ball is the carbon and the gray balls are the hydrogen. Okay. Similarly in ethane, there are 2 carbons. Now let's look at this structure really, really carefully. When there are 2 carbons, what happens? So let me try to draw this as we talk, because if I do that, then probably will understand better. So when I say ethane, so I went back and saw it has 2 carbons. My first job is I will first put 2 carbons. Then I'll think about everything. Now, how many hydrogens should this carbon have? Since it is already paired with 1 carbon, so it could have only 3 more hands, which means it could have only 3 more hydrogens. And I want to pause here. I want to ask you what I just explained about the structure of ethane, especially this part that a carbon is paired with 1 carbon. So only 3 arms are available for hydrogen. Is that clear to you?
Yes.
Yes, okay. And you know, so that's why when I'm going to write this condensed formula, I'm going to say this is C2. Okay, so this is going to be C2 and H6. C2H6. And whenever someone would give me, I would never panic. I would remind myself it's C2, then C must be connected to C. Each C must have 4 hands and 1 hand is utilized by 1 carbon. So I'm going to put the remaining here and I'm just going to make this structure. Okay, and that's why this ball and stick model fits really, really well. Similarly with propane, when someone says propane, this is what I would do. If I'm making it new and I've never done this before, I would go back. Okay, I'll be like, where is my, oh, propane, C3. Okay, let me try to draw this. I would say C3. So this is 1, this is 2, this is 3. That's how I would draw it. And you know, someone was asking, should I practice this? Practice this one, guys. I would challenge myself to practice this kind of thing more, because this is something that is going to come. Now this is 1 being used, so I can do this. Now what about this C? How many should I put in this one?
2.
2, okay. So we have 2 here and then 3 here, and then, you know, it's understood that I mean hydrogens. So that will be C3 and that will be H8.
I don't understand those. The ones that I don't understand is the one with the balls. I know. It's
Or
just
with the balls, okay.
I feel like it just get confused because I feel like I get it, but then I see the balls and I know I was already doing the homework and right. And
I
I
knew
was
exactly why you asked. I knew exactly why you asked.
Hold on, wait a minute. Can you go back? Why did you put 2 in the middle? I know.
Yeah, I love all these questions. Okay, so yeah, so let me just do it again. So when someone said draw propane, I did like 3 carbons, but oops, my pen is like acting crazy sometimes. But I'm going to do some counting here, and okay, so this is bond number 1 for this carbon, the middle only, okay? And this is bond number 2. You see that this carbon has successfully already formed 2 bonds, which means that it can only take now 2 more bonds. Do you see what I'm saying? Because it already formed 2 bonds.
Yes.
So it can no longer take more hydrogen. It must take only 2 hydrogens, because we know a carbon has 4 hands. Okay. So now with this, we have now formed the 3rd and the fourth. So do you see now why it can have only 2 hydrogen?
I don't know. I'm still kind of. I was
Okay.
following you at first, but I'm kind of.
Okay. Let's go back. Let's go back one bit. You have to remember this. You know, I found this really funny guy for you, and then put a C in his middle. Only 4. That's it. That's what is allowed.
Right.
Okay. No more than 4. Okay. And I'm going to explain you with a different example this time. So now you are going to help me because I have to get some help here. So butane. So I need 4 C's. So I made 1 C. So whenever someone says draw the structure of butane, so first I'm going to make 4 C's. Good, I'm done. Okay, now I need to have the rest of in the hydrogen. I'm going to just make streaks just for convenience. So this particular C, is it, and I can make circles for you that might help. So this particular C, okay. Let me pick a small, like a thinner thing. Okay. This particular C has only 1 bond. This C has 2 bonds. This C has 2 bonds and the last one has 1 bond. So I want you to appreciate that the inside C has already paired. This C already has 1 C on one side and 1 on the other. So 2 bonds are already formed. Similarly, this one, bonds are already formed. What remains is to form 2 more, which means that if this forms just 1 bond here and just 1 here, that would be good enough. Okay, so every time what we are doing is we are letting the carbon form only 4 bonds because we know that carbon cannot hold more than 4 bonds. It wouldn't be a noble or an ideal configuration. Okay, so that is why you can see that on the side, because it has only 1 bond, it needs 3, and it's in the middle, it has 2 each already, so it needs 2.
Okay.
Okay, and we can go over it again. And I know, you know, some of these things when you're reading for the first time, they don't make sense. And then, you know, they slowly start making sense. So, but we will go over it again if needed, okay? So, so which means that these are the alkanes, okay? And now there is alkene. So alkene is the one that has double bond. Now I think we should definitely be able to answer your question even better. So, you know, when you talk about alkenes, I'm going to say an alkene has a, you know, has a double bond, okay? So alkene has a double bond, which means I'm going to write here, the major thing is the double bond. So what do I mean by that? So I'm just going to write that whenever you have an alkene, you are going to see a C, double bond C, always. So when I say ethene, I go back to my table. Ethene has only 2, which means I make a C double bond C. Now you guys will see what happens, okay? This particular carbon has already formed 2 bonds, and this also has already formed 2 bonds, which means they can only form 2 more because they've already used 2 of their hands. They can only use 2 more hands, okay? And what about hydrogen? Hydrogen is a very nice guy. Hydrogen just wants only 1 bond and be done. So hydrogen doesn't care. Whenever you want 1 bond, and carbon and hydrogen kind of go together. Whenever carbon needs 1 bond, it calls hydrogen. Okay, so that way, let me erase this. That way what happens is that this particular carbon is satisfied because it has 4 bonds. This particular carbon is satisfied because it has 4 bonds. That is ethene. When you come to propene, it doesn't mean that everything is double bond, only 1 double bond. You got to be careful now. If someone asked me to draw the structure of protein and I had not seen this, I would be like, okay, I know there is a C double bond C, so let me just start with that, and then a single C. And now let me try to think of all the hydrogens that I need, okay? So I'll say, okay, I need 1 hydrogen, for the end, I need 3, 1, 2, 3, that makes this carbon complete. For the middle, how many do you need?
2.
You need just one. Yeah, looks like from wherever I copied this figure, this was wrong. Yeah, I'll have to replace this. I'm pretty sure that that might have confused you. I have just simply got it from somewhere else. I didn't draw this figure. So this one has only one bond and this one has two bonds. I'm sorry, I think I made a mistake. You should have corrected me. You should, no,
I was about to say since 6H, so it shouldn't be 6 and 4 8s. I'm confused now.
say that again. Sorry, you said,
So that is like H8, so shouldn't be 8 H's. So why are you crossing one of the H's down? Would that bring down to 7?
okay, yeah, they didn't do the structure right. I'm sorry.
Couldn't that H you crossed off be moved to the last C?
Absolutely, Jake, you are right. Okay, I'm gonna move it here. Yeah. So,
You cannot have one next to a double bond, pretty much.
I mean, you can have one, but I mean, it cannot have more than 4 hands. So you cannot have that. That was a mistake from wherever I picked the structure. Yeah, sorry about that, guys. I'll replace this one. I don't know how, because I didn't make them. I was thinking because C3H6 just looks right, and I didn't really pay a whole lot of attention. So so this would be, it would be looking like this. Yes, this H will not be there. This has 4, this is 4, and this is 4. That's another thing you need to learn in general in science. When someone teaches you something, and you find, or somewhere you read something and you find that something that is being shown to you is wrong, you point it out. You say, I don't think this is right. Or you can just say, I don't think that structure is correct, or I don't understand how that works. So please feel free to point out if there is something that you find a mistake somewhere. But in general, that's how it works. And it actually, it actually kind of goes even beyond that, because if you see the alkynes, these are the alkyne, they have 3 bonds. Now you see the fun in the middle, there are 3 bonds, which means that each carbon only has 1 free hand available. And that's the ethyne. And that's how it works. So if you see the propyne, again, you may feel like I'm rushing. I'm actually not trying to rush. I'm trying to explain it to you that this is not going to be that hard. Propyne means you have a C here. So first thing when I see a propyne is I will draw this triple bond, and then I will draw this, because I want to make sure that 1, I have completed the prop part, which is 3. Second, I have completed the wine part, which is the double bond. Now everything is done. Now what remains is fulfilling the hydrogen. So this is 3, so 1 hydrogen. This has 4, no hydrogen. This has 1, so 3 hydrogens. Do you think it's making sense or not?
Yes, it's making
Yes,
sense.
it is.
It does, right? Yeah, slowly it'll start making sense. And this is fun to work with. So if you need any practice, this is what like I would work on. Like if I would be you, I would try to do these structures. I'll hide this and try to do these structures by myself and see, am I getting this? That's really, really important. And that's very important for your oral exam too, because I won't show you complicated structures, but I show you structures like this. And if you're able to answer, you get the straight up 20 points, it's very, very easy. Okay, so what happens in other cases? So when there is alcohol, we need to recognize what group it is. So for example, alcohols are OH. So now we have the O. Gosh, we didn't talk about O at all. So let's just go back and see how many hands does O need. And you will tell me, I'll not say a word. I will not say anything. How many electrons does O need to make it happy?
Can you repeat the question, please?
It needs 2.
How many electrons does O need to make it like complete its shells?
2.
2.
2. Okay, so which means that we all know hydrogen needs 1, carbon needs 4, oxygen needs 2. Remember H2O, that is why O has 2 hands, both are hydrogen. Okay, so that means that when we come to alcohols, which is right here. Okay, so when you come to alcohol, let me just expand this for you a little bit and say that oxygen would be like this, and the hydrogen is like this actually. I know it doesn't say that, but that's what it means, which means that oxygen on one hand was connected to the carbon and the other hand is connected to the hydrogen, which means that now as a chemist person, we are looking at this from a chemistry standpoint. You know, sometimes we'll be on a biology side, sometimes we'll be on the chemistry side. So from the chemist standpoint, we know that oxygen shells are full, hydrogen is full because it needs only one, carbon is happy because it has 4, everyone is happy. Okay? And so that's all we care. Now, let's come down to the structural part. Someone said methane. Okay, well, methane is only 1 carbon. And someone said all. So I always take care of the prefix and suffix. So prefix C, suffix OH. And then I'm going to fill up the rest with the hydrogen. That's what I do. And for I know some of you said like the ball structure is the one that's confusing. Yeah, I kind of agree. Actually, if we were, let us say we were in person, then maybe I could have gotten some for you. And actually ball is very, very fun to work with. You know, you can use thermocol balls and try that out. And I'm going to, maybe in the next class, I can show, I have done with like Play-Doh kind of thing. I can show to you, but you know, it needs to have the 4 hands and that's exactly what it is. And the black is carbon and the red is oxygen. That's why I showed the oxygen here like that. So ethanol, again, whenever someone says me ethanol, I'm not going to panic. I'm not going to be scared. I'm going to look at the prefix and the suffix separately. Say ethane, 2, all OH, fill up the rest. Same thing for propanol. And once I'm done with all this, I'm going to think a little bit more. I'll say, hey, I'm going to be in dental hygiene. So what is the use of alcohol? I'm going to be in nursing. What's the use of alcohol? Well, it is used as a disinfectant. I know it is used as an antiseptic. So here, these are some of the things that I can use it for, or I will be looking at some of those applications. So you looked at the atoms, you look at the structure, and then you go back to the biology and applications. Okay, similarly, now it all becomes a game of how much of the functional groups you can remember. For example, now we're talking about the aldehydes. What is aldehydes? Okay, aldehyde are always in the end. They have the CHO group, okay, because they're in the end. So C double bond O is fine, and it is connected to the C is fine. And then it is the H, which is coming in to fill the 4 and the 4 bonds. Now you may ask, what is this R suddenly? Like you never really talked about an R. So R is the general name for that side chain, and this is the side chain in this case, which is the CH3. And if you see here, there is CH3 with CHO. Now there is, you can see this is the this is 2 carbon, so this has to be ethane with the ul, ethanol. Ethanol, that's what it is. Similarly, this one, methanol. Trick to remember is that suffix table. You go back, you print it out, or you write it down. Keep remembering OH, ethanol, CHO, aldehyde, C double bond O, ketone. You might say, wait a minute, you got me confused. Here you said C double bond O, now you are saying C double bond O again. So let me clarify this. Ketones are always in the middle. They are squished in the middle. You know, ketone is squished in the middle. And aldehydes are always in the end. So they have that extra free arm where they put hydrogen. So aldehydes essentially become CHO, whereas a ketone becomes only C double bond O. And it's kind of funny because on one side is some carbon chain and on the other side is some carbon chain. Okay? So you can see that this is something that has two different functional groups. One is the methyl group and other is the ethyl group. Okay, but if you count them together, it is 4 C's, and that's why it is called butane on. That was butanol. If it would be, this is butanon. I know this is going a little bit faster. I hope this is going okay for you. Is that okay?
Yeah,
Yes.
it's fine.
Yeah, okay. And you know, I know we are at 3:35, so it'll go on a little bit more, maybe 10 more minutes before we finish the functional groups. I just want to let you know time-wise how we are doing. Okay. So acids. So there is carboxylic acids, which is COOH. Okay. Now you can think, why are these dots given? Whenever you see dots, Lewis structure. That's why sometimes we just see those dots. Don't worry about these dots. They're not important here. Okay. Just look at the bonds. And also always think about these things. So always, I'm going to remind you one more time, like when you're thinking of a C double bond OH, O has a double bond. So this is good. Does C have 4? Yeah, I can see 4. Does this O have 2? Yes, I see 2. And this H has 1. So you will never find a compound ever, which is not following these rules. That's why we learned them. So if you see the COOH, that is in the end, and it is joined to the R or the side group, which is the CH3. How many carbons? 2. What is this called? Ethanoic acid. Now I need some help drawing propanoic acid. So propane, so 3. So I say C dash C dash C. That's the first thing I do. Someone says draw propanoic acid. I'm like, okay, I first make the propane and then I make the acid. Okay, so I did that. Now I know that I don't have to worry about this. So I'm going to worry only about this C. So let me start worrying about that. So this particular C has 2, so it needs 2 more. This has only 1, so it needs 3. You see, it wasn't that hard. If I know the meaning of the prefix and suffix, I can just about make anything. I want to ask you, if you were given a challenging question like that, like butanoic acid or something, do you think you would be okay drawing it?
Yeah, from the way you just explained it.
Maybe.
Maybe. Okay, so that's what we're going to work in the assignment, right? Yeah, so, that would be what needs a little more practice. But I hope it's not. I know someone said to me, like in the beginning, like, hey, it's looking like cryptic language. I hope it's not, guys. Like really want to make this something which is easier than that. Okay, so then the next one is Easter. So again, we are doing these pairs together. Do you notice that this was COOH and this is COO with a C? So COO in the middle, just like aldehydes have CO in the end. So this becomes CHO and the ketones have in the middle. Just like that, acids have 1 in the end and esters are in the middle. Okay. And so again, if you see here, there is, if someone asks you to make this methyl ethanoid, there is a little bit of challenge because you are navigating here 2 things. One is the methyl, which is the CH3, and the ethanoid. So you have to make the C double bond O and the C, and then you just fill it up. So if someone asked me to make a methyl propanoid, how would I do it? I would say, okay, you asked me to make a methyl propanoid. So first of all, I know that I need a C, and this particular C will have I know this is going to have a double bond with an O. So I'm going to make that. And this has an O. This is not great, but that's fine. And then wait a minute, I think I did a mistake. Okay, I'm gonna just draw here. I need to have one more C. That's why I said it. I made a mistake here. Okay, so this would be contributing to methyl, and this would be contributing to the propanoid, because I'm going to, and I should also put a O here to not make it confusing. Like I said, the strategy is simple. You first take care of the whatever is in the front, the prefixes, and then you take care of the suffix. So methyl is this part, and then propanoid. So these three are together. Now remember, there should not be any break in between. They have to be together. Okay. So again, this one is methyl. This is the ethanoid. I might have said the other way, but this is the ethanoid. So these three, or let me just circle this in a different color. So these three are together. That contains the propanoid part. And this is your functional group, and that's your methyl. So this essentially would be methyl propanoid. Now you may say, where are the H? Well, you're going to fill them up just a similar way. You're going to say this is one H. So I'm going to fill this up with 3. I'm going to similarly make 2 here. And this carbon, it doesn't need anything. Now, also, I know that none of you asked this, but methyl propanoid, why do we have these 2 names in here? We have these 2 names, or the breakage in the names, because the O came in between. And when the O comes in between, you can't really count this C with that. So I know you see 4 C's and you'll be tempted to say butane something, but the reason you are not saying that is because of the break in the structure. So again, as I explained to you, you do more things, it'll become more clearer. And if you do assignments and you think you need more practice, the books have assignments, the referral books. Also, you can ask me, like, we need more practice, so give us more questions. Okay. So then there are ethers. They have a COC. They're different from this. That was a C double bond. Oops. The previous one. Wow, it's closed. How did that happen? My computer is tired. Where did oh, the PowerPoint got closed. That's interesting. So while it is opening, what do you think? Like, are you guys getting a little bit grip on this thing? Yeah?
Yeah, I
Yes.
definitely have a better understanding.
Okay, that's good. That's good. And it does take time, guys. You know, these things, like, always tell people science is not for the weak. So you guys are brave and you will be just fine. So we are going to just look at these functional groups. We are almost finishing that. And then there is what is remaining is not something like a whole lot remaining.
I have a question.
Yes.
Where will you be uploading this recording? I just kind of want to look back at it sometime.
Of course. I will be recording it exactly where the module 1 is. And I have already uploaded previous year's recording, which means that if you wanted to go back, you know, uploading a recording at YouTube takes like a little bit of time. So I want to do it as soon as possible, but I can tell you it's not going to happen in next 15, 20 minutes. It takes a while to process. It's a longer than 1 hour recording, but good question. Anything related to module 1 will always be in module 1.
Okay, thank you.
Okay, so you don't have difficulty looking. So those are ethers. And again, you can see this is called a skeletal structure. I know it looks really, really funny, but you will use a lot in acids. Let me just take one moment to explain to you. When you see structures like this, you'll be, instead of thinking too much, you should know that these corners where there's, these little things, where edges where there's nothing, those are carbons. Okay, those are carbons. Because if it was anything else, it would be something which is given. And then you can always make the hydrogens in here. Also want to appreciate that here, different structures, even if the structures look different, they actually mean the same molecule, you know? So that's something that you need to know. And, you know, you probably be, when you are like running around in a hospital or something, you will be coming across some structures, some things, in the sense, like, not always like this. You might just quickly look and something says something ether or something ester or something, you know, whatever the compound is. So you should be able to get immediately, hopefully a picture of what it kind of, in your mind be like, okay, this is what it looks like. So there is amines, and the amines are important. You will see that you are going to work with protein, like work on one of the modules, which is protein. So then you will look at amines as well. So there is this methylamine. Now I want to remind you about nitrogen. Okay, so to remind you about nitrogen, I want to take you back to the table, and you have to tell me how many hands does nitrogen, how many bonds does nitrogen want to form?
1.
1. I thought it should be at least.
It should be 3, right?
Should be
Should be
3.
at least 3. Yeah. Oxygen 2. Yeah. So let us see. Go back there. Okay. Yeah. And don't look at these. This will confuse you. So only 3 bonds are being formed. It's funny, once you start looking at things like that, whenever I see structures, I'm always tempted to see whether they did the structure right. And you can see, we can find here, there are 3 hydrogens with a 4th bond. So that's 4 hydrogens are satisfied. This hydrogen has 1, nitrogens have 3, carbon has 4, hydrogen is 3. So again, looking at that and also looking at why this is, how these are named. So if you see here, this is methylamine. These are 2 methyls, so dimethyl, and you know why it cannot be called ethyl, because these carbons are interrupted by a nitrogen. Carbons don't like to be interrupted. They're like, if we are together, then only call us ethyl. If we're not together, we are separate. We're not going to be together counted. And similarly, this is trimethylamine. So I know in past, these structures would be looking complicated to you, but as you go by, this might probably make a lot more sense. And then there is amides. Amides are something, again, like I said, once you get to the protein part, you'll know, but it's kind of nice to know that this is the C double bond or NH2 bond right here. There's some errors here and there. The C double bond or NH2, that's the functional group. Again, that's our, this is our, the prefix, and that's the suffix. And you may say, why is it called acetamide? Because in the table, you never talked about acetamide. So acetamide is that the older name, acetic acid is an older name. It stands for that ethanol, basically. The 2 carbon is acid, acetamide, or, those kind of acetic acid kind of thing. So it's an older name, but some of the places I have used still 1 or 2 of the older name just because it came with the figure. Also, it helps you familiarize with people would still write like that. That's it. So here is the learning check, and try to do all of this, like really honestly sit down and see, okay, I know, I understand this. If not, then the learning checks are such that you can go back and see, oh, how is that, or what is that? And let me go back and remember this. I think that's about it. I think that there is just 2 slides left, and that is on isomers. And the word isomer we used just now, because we were talking about, we were not using in isomer context, we were saying isotopes. So isotopes were same atomic number, but yet different neutrons. So there is a little bit of difference, but they're still belonging to the same atom. Like it could be a different thing within the hydrogen, or a different isotope of hydrogen, or a different isotope of carbon. So isomers are like that. They have the same number, in the sense like they're a little bit similarity. They have the same number and types of atoms, but they're differently arranged. For example, when you see propanol here versus the methyl ethyl ether, you can see here, let's count the number of carbon. And for me also, it's very tempting. I always want to count the number of carbons in hydrogen. So that is C3, and then that is 1, 2, 3, H8 and O. Okay, got this. Now let me try to be doing an honest job. I know these are isomers, but we'll still count. C3, 1, 2, 3, 4, 5, 6, 7, 8, H8O. Okay, yes, they have the same, exactly same, number of atoms and different types of atoms, but they are different because one of them is propanol and the one is methyl ethyl ether. And now these structures don't scare me anymore, because whenever someone said propanol, I'm like propane, 3, all, OH, the rest is hydrogen, propanol. Methyl ethyl ether, methyl, methane part, ethyl the ethyl part with the ether. And then I compare them and I see, oh yeah, they do have the same configuration. And then comes the most fun part, and the last part here, that is the, of course, there is the geometric isomers and the optical isomers. And the fun with the geometric isomers is there is a cis and trans. So the way I remember it, I would just want to share with you is cis. I say cis and same kind of sounding similar. So cis and cis goes with same. So when they are on the same side, I call them cis. Okay? And when they are on the opposite side, I call them trans. Okay? So same side is cis and opposite side is trans. Because they have the exact same formula, but they're going to be ending up looking different. They have different properties too. You will see that it makes a lot of difference once you start studying fats. You might have heard of trans fat and cis fat, and that's where you would see them. Optical isomers. Okay, so optical isomers are the ones that are mirror images of each other, but they cannot be overlapped. And the biggest example of that is, okay, yeah, biggest example of the mirror images one is your hand. You put your hand in front of each other. Okay, well, the thumb is like a mirror image of the other thumb, and the fingers that they're all matching. But when you put your hand on top of each other, you know, they don't put them as if you're combining mirror image with each other. You will see that your thumb sticks out on both the sides and the fingers are not even matching. So it's the exact same set of fingers and thumb, but arranged differently. So that's an optical isomerism. Looking at the mirror images, looks the same. Overlap them, not the same. Okay, so we are going to learn more about this. Also remember, they are also 3-dimensional. You know, you have to take a look at anything which is dark. Sometimes things are shown in dark, that's sticking above the plane. And we're going to talk about this more next time. And anything which is going below is the bond below the plane, and the ones that are straight are on the plane. So I'm going to get some clay model and I'm going to show you with that. Okay, let's see. Okay, so with this, I'm going to just stop sharing. And I want to know if you have any questions. Office hours are optional, but I highly encourage you to attend them. I know that there were people who attended, just statistically speaking, there were people who attended the office hours still, and most of them had A's. Not because I'm telling anything special, but they were really, really keeping up to the work.
Sorry, when you mean office hours, do you mean the Sundays meeting?
Yeah, that's it. Yeah.
Okay.
Okay, anyone has any questions? You can ask now. If you feel like you're done, you can also leave. I'm going to stop recording now.